Architecture of TMS 320C5X series. It is one of the important questions in this unit, and it is a repeated question. It is a fixed point, a 16-bit processor running at 40 MHz. Single instruction execution time is 50 nanosecond. Architecture uses hardware plus on-chip peripherals and on-chip memory. It is divided into 4 blocks. First one is bus structure, second one is CPU, third one is on-chip memory, and fourth one is on-chip peripherals. This is the architecture diagram where you can see a data bus, bus structure, maximization of processing power with high degree of parallelism and MAC operations. It has a 4 important bus. Program bus carries the instruction code and immediate operand from program memory to CPU. Program address bus provides the address to the program memory space for both read and write. Data read bus interconnects various elements of CPU to data memory. Data read address bus provides the address to access the data memory space. Central processing unit. It consists of central arithmetic logic unit called as CALU, parallel logic unit called as PLU, auxiliary register arithmetic units called as ARAU, memory mapped register called as MMR, program controller called as PC. Let us see one by one. Central arithmetic logic unit CALU performs 2's complement arithmetic. It consists of 16 cross 16 parallel multiplier, 32-bit accumulator, 32-bit accumulator B register for storing the quotients and remainders, product registers, shifters. 16 cross 16-bit hardware multiplier is capable of computing signed or unsigned 32-bit product in a single cycle. The result is stored in accumulator. Parallel logic unit. It is the second logic in CPU. It executes logic operations on data without affecting the content of the accumulator. It can directly set, clear, test on any data memory location. The result is stored in first operand's memory locations. Block repeat registers. It has 4 important registers: RPTC, BRCR, PASR and PAER. All are 16-bit length. RPTC, it holds the repeat count in repeat single operation and it's loaded by the RPT and RPTC instructions. BRCR, it holds the count value for the block repeat features. This value is loaded before the block repeat operation is initiated. PASR, the block repeat program address starts register indicates the 16-bit address where the repeated block of code starts. PAER, the block repeat program address end registers indicates the 16-bit address where the repeated block of code ends. Instruction registers hold the opcode of the instruction being executed. Interrupt registers, it is a 16-bit length. Interrupt mark registers individually marks the specific interrupt at required time. Interrupt flag register indicates the current status of the interrupt. Program controller, it consists of following elements: program counter, it has a 16-bit length. Hardware stack, program memory address generation, status and control registers, instruction registers. Circular buffer registers, it has 4 registers. Circular buffer register, it has 5 registers. As 2 circular buffer registers as 2 concurrent circular buffer: CPSR1, CPSR2, CBER1, CBER2, CBCR. On-chip memories of 224 kilo word length of 16-bit length. 64 kilo word of program memory space, 64 kilo word of local data memory space, 64 kilo word of input output port, and 32 kilo word of global data memory space. It has a program read only memory, data program single access memory, that is SARAM, data program dual access, that is called as DARAM. On chip peripherals: clock generator, hardware timer, software programmable wait state generator, general purpose input output pins, parallel input output port, serial port interface, buffered serial port, TDM serial port, host port interface, user unmaskable interrupt. Addressing modes. There are 6 types of addressing modes: immediate addressing, indirect addressing, register addressing, memory map register addressing, direct addressing, and circular addressing. Let us see one by one. Immediate addressing handle the constant data to the accumulator immediately. For example, LD 80, A loads an immediate value of 80 into an accumulator. Indirect addressing, it uses auxiliary register to hold the address of operand in memory. The selection of AR0 to AR7 with the help of auxiliary register pointer is powerful indirect addressing. It has 7 types: auto increment, auto decrement, post indexing by adding the content of AR0, post indexing by subtracting the content of AR0, single indirect addressing with no increment, single indirect addressing with no decrement, bit reverse addressing. Register addressing, it uses operand in CPU registered directly. Address comes from two special purpose memory mapped register in CPU: block move registers and dynamic bit manipulation registers. Memory mapped register addressing, it uses on-chip peripheral registers, first 9-bit representing address of the page, remaining 7-bit representing opcode and operands. Direct addressing, CPU uses the data specified by data page pointer. Data page pointer is a 9-bit field contained in the status register. In this mode, the address of the operand is obtained by concatenating the 7-bit DMA with 9-bit of the data page. Circular addressing, circular buffer starting address register 1, circular buffer end register 1, circular buffer control register.